And here's some hints. Well, just it's basically flat out the answer. So hopefully you've looked at the assignment, but I've had a lot of questions and people wanting to check to make sure they're doing it right. So here are the answers explained. So hopefully this will help you. Let's look at the assignment 8.5. Number 1, graphing 2 tangent of x. So first thing to notice, it's the tangent function. So it is going to look like these down here. It's a positive tangent, so it's not going to be this one or this one, because those represent the negative tangent function. So we look over at this one, and we notice that it has a 2 in front, which represents the amplitude, or the vertical stretch. And if we look at this one here, this one crosses right there at pi fourths and 1, which is not being vertically stretched. This one, it crosses at pi fourths and 2. So this one here is the correct one because it is being vertically stretched at 2 units. And so the answers are the graph is a vertical stretch by a factor of 2. Number 2. So this one, all right, number 2. Let's first look at b, which is pi, and let's find out what the period would be. Well, the period would be pi divided by pi from that formula in your notes. So pi divided by pi is just 1. So that means that the period goes for 1 unit. And notice on this one, it does go from 0.5 to 0.5, negative 0.5. So that one might work. This one goes from like negative 1 to positive 1 point something, so it's not this one. This one goes from negative 0.5 to 0.5, so that one might be a possibility. And this one is way too stretched out, so it goes, from negative 1 to positive 1, so that's 2 units, not 1 unit, or 4 units, 2 units. So it's going to be one of these two. And the next thing you'd look at is the 1/2. And the 1/2, what that makes it do, and what that does is the amplitude is 1/2. So if we look right here, this one, the amplitude, so we look at the position over here, and this would be like half up to 2, so that's not it, but this one is over and then up half. So there's the amplitude of a half right there. So this one is a horizontal shrink of 1/2. So that first number is either going to be horizontal stretch or a shrink. This one was a shrink because it was a half. And then the vertical shrink of 1/2 also. And you could put these in different orders. You could have done vertical shrink of 1/2 and horizontal shrink of 1 over pi. Either one of those would work. Okay, number 3. So this time we have the tangent of 2 pi x. So again, I'm going to start with the period. The period would be pi over b, which is pi over 2 pi, which would just be 1/2. So the period is 1/2. So as I look at these right here, 1/2 means that it would go from negative 0.25 to positive 2.5, and that one works for that. This one goes from negative 1/2 to positive 1/2, that's way too wide. This one goes from negative 0.25 to positive 0.25, so it could be this one. And this one also looks like it goes from the 0.25, so we've narrowed out this one right here. Now this 1/3, that is kind of like what we saw in the earlier one. It's going to make it do that shrink thing. So as we look right here, that first value right there is going to be over 1 up 1/3, which that gives our amplitude of 1/3 right there. So that's the answer. And this one is a horizontal shrink of 1 over 2 pi. So to find that, you would take the period, which is 2 pi over 1, and flip it. The vertical shrink of 1/3. Okay, the next one, number 4. Which of the following are asymptotes of the graph of 3 tangent of 4x? Well, to find an asymptote, you take pi and divide it by 2b, which is 4. So b is 4. So we're going to take pi and divide it by 2 times 4, which is 8. So we're going to look at multiples of pi over 8. So we know that we're looking at multiples of pi over 8, and it's going to be odd multiples, because if you add pi over 4, which is the period length, then you would get like 3 pi over 8 and 5 pi over 8 and all of that. So then if you subtract enough, you would end up with negative 5 pi over 8, and that would be an odd multiple of pi over 8. So that's why both of those works. Number 5, we're looking for the equation here. And so we're looking for a value for A and a value for B. And as we look right here, we see this is a tangent function. And this first value right here is over pi fourths, and it's up 6. So that's the vertical stretch of a value of 6. So that's where we get the 6 from. And the period length is pi units. So to find the period, you take pi and divide it by b, which is also pi, and that gives 1. So the 1 in front of the x, so your answer would be 6 tangent of 1x, or just 6 tangent of x. And that's how you would write it. Number 6. Again, we're looking for the values of a and b. And I'm just going to look at this first value right here. And if you notice, over 1 unit, and we always go 1 unit halfway to the asymptote. And notice it crosses up here at 2. So it does have a vertical stretch of 2. So the 2 does go in front of the tangent. And then b is found by taking the period, and so you would take the period on here goes from negative 1/2 to 1, so the period is 1, and so then it would be pi over b, so 1 equals pi over b, and then if you do the math and find that out, you find that b is equal to pi. So b is pi, so it's 2 tangent of pi x. Number 7, so this one, 3 tangent of x. So first off, I'm going to notice this is a tangent, this is a tangent. These two are negatives, or inverses, so we're not going to use those. And it has a vertical stretch of 3, where this one is over 1 up 3. This one is over 1 up 1/2. So it is definitely that first one there. And it is a vertical stretch of 3. That's where the 3 came from. Number 8. So which one is the tangent function? And first thing to notice, there's really only 2. This one is a negative tangent, this one's a positive, but let's just check to make sure. This one has a vertical stretch of 4, which is over 1 unit up 4, so that one does work. And number 9, write a rule that represents a translation pi units right followed by a horizontal shrink of a factor of 3 of 2 tangent of x. So we keep the 2 with it because we're just taking that and translating that function there. The translation pi units right gives us this negative pi being subtracted from the x value. And then the horizontal shrink by a factor of 1/3. Horizontal shrink is opposite of what you would think it would be. So instead of 1/3, then we take the the reciprocal of that. So we put a 3 right here that represents that horizontal shrink by a factor of 1/3. And that's the equation. That's kind of the tricky part there, that horizontal shrink, remembering how we get those. And finally, number 10, describe the error. So tangent of x has been translated to 2 tangent of 5x. And it says it's a vertical stretch by a factor of 5, and a horizontal shrink by a factor of 1/2. Well, we just noticed in the last one that the horizontal shrink affected the number in front of the x. So the horizontal shrink would be a factor of 1/5, and the vertical stretch would be a factor of 2. So the horizontal and vertical shrink factors are switched, and the vertical stretch is a factor of 2 because of the 2 in front. Oops. And the horizontal shrink would be 1/5 or 1/5. And there you go.